Hi, welcome to this video on relative atomic mass. Now, relative atomic mass is just the atomic mass of atoms, but relative to their isotopes. So different atoms might have several different isotopes. So we get a weighted average of their mass. To calculate relative atomic mass, we use this equation. And that is the relative atomic mass is equal to the mass of isotope A times the percentage abundance of A. We then add on the mass of isotope B times the percentage abundance of B and divide by 100 when we're dealing with percentages. So there are two different ways this information could be given to you. The first is in a graph, a little bar chart. So we have here our percentage abundance by our mass of isotope. We see we've got two isotopes, 10 and 11. The equation we've just seen, we saw just two isotopes involved, but it can be expanded. We go to isotope 10 has a abundance, or percentage abundance of 20%. And our isotope B has an abundance of 80% with a mass of 11. So to work out our RAM, we would do mass of isotope A, which is 10, times its abundance, which is 20, plus the mass of isotope B, 11, times its abundance, which is 80, and divide those two when added together by 100. This would give us 200 plus 880 over 100, or 1080 over 100, to give us a final relative atomic mass of 10.8. Now, an average mass for this atom would have been 10.5, halfway in between. But it's now, when it's relative atomic mass, we see it's here, it's 10.8. That's because most of the isotopes were isotope 11. If you were to have 100 atoms of this particular element, 80 of them would be 11, and 10 of them would be, and 20 of them would be isotope with mass 10. So that's if you get information percentage in a bar chart. The other way is in a table, and this time we've got three isotopes, so we're going to expand our formula now. It can be done. So we've got isotope A and isotope B we can put in, and then we're just going to add isotope C in the end anyway, because we're working with percentages. We can still carry on and we just divide by 100. So A, we've got 28 times 92.23 plus 29 times 4.68. These are masses times by their abundances, plus I'm just adding a third one on, and I could add a 4 for a fifth if I needed to, times 3.09, divided by 100. Right, let's get these. So that will be 2,582.44 plus 135.72 plus, easier, 92.7 over 100, squeeze that board up a bit, or 2,810.86 over 100, once we've added all of these in, to give us an isotope mass. We'll round it down to 28.1. You can look at the periodic table and identify what the compounds are, and that is relative atomic mass.